Bridge failures can be catastrophic, with a variety of causes ranging from design flaws to natural disasters. Here are some of the most notable bridge failures in history. 1. Tacoma Narrows Bridge, 1940. Often called Galloping Gertie, this suspension bridge in Washington state famously collapsed due to aeroelastic flutter. Strong winds caused the bridge to oscillate violently until it disintegrated. 2. Quebec Bridge, 1907 and 1916. The original construction of this bridge over the St. Lawrence River in Canada failed twice. The first collapse in 1907 was due to a design flaw and overloading. The second collapse in 1916 was caused by structural deficiencies and poor construction practices. It remains the longest cantilever bridge span in the world. 3. Silver Bridge, 1967. This suspension bridge spanning the Ohio River between Point Pleasant, West Virginia, and Gallipolis, Ohio, collapsed due to the failure of an eye-bar in the suspension chain. The failure was exacerbated by corrosion and poor maintenance. 4. Angers Bridge, 1850. In France, this cast-iron bridge collapsed due to the design's inability to handle the weight of an unusually heavy train crossing it. The failure was a significant event in the history of bridge engineering, highlighting the limitations of cast iron. 5. Belfast's Queen's Bridge, 2001. This bridge in Northern Ireland suffered a major failure when a ship collided with one of its piers. The collision caused a significant structural failure but fortunately did not result in loss of life. 6. I-35W Mississippi River Bridge, 2007. In Minneapolis, Minnesota, this steel arch bridge collapsed during rush hour due to a combination of design flaws, structural overloading, and inadequate maintenance. 13 people died, and many more were injured. 7. Cleddau Bridge, 2017. This bridge in Wales failed due to a combination of structural fatigue and design issues. The collapse of a major span led to significant traffic disruptions and highlighted the need for rigorous maintenance checks. Avoiding bridge failures or collapses involves a multifaceted approach encompassing design, construction, maintenance, and monitoring. Here are several key strategies to help ensure bridge safety. Thorough design and engineering. Adherence to standards. Follow established engineering standards and codes for bridge design. Load testing. Design bridges to accommodate expected traffic loads and environmental conditions. Material selection. Use high-quality, durable materials appropriate for the bridge's location and purpose. Seismic design. Incorporate features to withstand seismic activity if the bridge is in an earthquake-prone area. Quality construction practices. Skilled workforce. Employ experienced engineers and construction workers. Proper inspection. Ensure that all construction phases are inspected and comply with design specifications. Quality control. Implement rigorous quality control procedures for materials and workmanship. Regular maintenance and inspections. Routine inspections. Conduct regular visual and structural inspections to identify and address issues early. Routine maintenance. Perform scheduled maintenance tasks, such as cleaning and painting, to prevent deterioration. Repair and rehabilitation. Address minor issues promptly before they develop into major problems. Monitoring and technology. Structural health monitoring. Use sensors and monitoring systems to track the bridge's health and detect early signs of distress. Load monitoring. Implement systems to monitor the load on the bridge in real time, especially for critical structures. Load management. Weight limits. Enforce weight limits to prevent overloading. Traffic management. Control and manage traffic to avoid exceeding the bridge's design capacity. Emergency preparedness. Response plans. Develop and practice emergency response plans for bridge failures or severe damage. Public awareness. Educate the public and transportation authorities about safe practices and emergency procedures. Environmental considerations. Hydrological analysis. Assess and manage the impact of water flow and flooding on bridge foundations. Weather impact. Consider the effects of extreme weather conditions, such as heavy snowfall or high winds, in the design and maintenance plans. Regular review and updates. Design updates. Periodically review and update bridge designs based on new research and technological advancements. By integrating these practices into the life cycle of a bridge, from design and construction to maintenance and monitoring, the risk of failure can be significantly reduced.
Please like, comment and subscribe on this channel.